Hello, good afternoon. Looks like we're live. I'll wait a few seconds. Hopefully we get a few more people to join us. My name is Melissa, and I will be your blue coat for our teacher session, professional learning coding series. Don't see anyone in the stream just yet, so I'll wait a few seconds. Just waiting for folks to join. And now, of course, this is going to be put up on the internet. The recording is going to be there after the live session. So if you join a little bit late, I see a few more joiners. Awesome. Again, my name's Melissa. I'll be your blue coat for this session here. I have also with me, sort of behind the scenes as a moderator, Brendan. He's going to pop in for a second.
Hello.
He's helping me out with comments, questions, and things. So if you have any of those, pop them into the chat.
All right. Good luck, Melissa.
Thank you. So we're doing our first session of professional learning here, our coding series. So again, my name is Melissa. I'm here with Science North. I'm going to lead you through a session here today all about coding. Now, I think I shared my screen here. You can see, there we go. Here we go. Get into the groove here. So before we get started, I just wanted to acknowledge that we are on the traditional and ancestral lands of the Atikameksheng, Anishinaabeg, and Wanapitei First Nation. So I'd like to also acknowledge the Métis Nation for their cultural and economic contribution in this area. These lands sit in the Robinson-Huron Treaty Area, and as we are all treaty people, it's important for us all to be thinking about what treaty area we live in and are an active part. So let's take a moment to appreciate the land that we are on by acknowledging the traditional territory and treaty area that you are located in. So this is a province-wide workshop. So if you are not in the Robinson-Huron Treaty Area, you want to shout out to your treaty area, you can do so in the comments. So I've got a few slides here. I just wanted to quickly sort of overview some of the things that Science North has to offer. So these slides are just sort of placeholders. I wanted to sort of flip over to the website for a second so you can see where we've got some of these resources here. So I'll swap my screen share. All right, so here's our Science North sort of landing page, sciencenorth.ca. You can see my cursor when I scroll. That's perfect. Where you want to end up if you're looking for any of that teacher resource, tabs and things. You want to get to learn here down to schools. You can see there's the virtual learning packages slide that I had up a little earlier. Teacher workshops. So this is our landing page just for teachers. Now, where all the things that are going to live from our workshop today are over here at this educator resources. So education.sciencenorth.ca. We click here. And we've got this professional learning coding series. So I'll scroll here, November 16, that's us, that's today. So all of the things that you would need to do this lesson in your classroom is right up there on the web. So let's get back to that lesson. Perfect. So our workshop goals here, Science North is always dedicated to getting students excited, thinking about science. Right now we are trying to do that. We're relating all of our science concepts to coding. So the part of the goal is to get students excited about science, but also to provide support for teachers in these unprecedented times. So a lot of what we're doing is going to give you some fun ideas about integrating coding into your classrooms. So our session today is going to cover a lesson called Patterns in Nature that's geared for grades 1-2. So the first session our session is separated into 2 parts. So today we're going to cover sort of half of that lesson, and tomorrow we're going to cover the other portion of it. So the lesson plan document covers all of these 3 activities. The slides from this presentation will also be available. We have a few handouts, as you saw when I led you to our website, so those are all there. So we're going to cover the offline activity, the coding activity today, and get into the math activity next session. So we're going to take a look at patterns. And why are we taking a look at patterns? Because patterns essentially are codes. So when we're when we say coding, what does that mean? Well, usually we mean a set of instructions that we're going to give to a computer. And the more that we can recognize patterns and series within our coding, sort of the easier it becomes, or the more elegant and the more efficient our code becomes. So one of the first sort of steps into coding is recognizing patterns. So I'm going to go through a few things as you might present this to your students. Now, again, I really like this lesson. There's a ton of different jumping off points. I sort of went with the things that resonate with me, the things that I sort of geek out about, but you have the opportunity to take the lesson and go in a lot of different directions. So, just know that I'm not doing the whole comprehensive thing that you could. If you do like this lesson as is, obviously you're welcome to take it into your classroom in any form that you like. So patterns are codes. Now, I've got a little cute short pattern here. Now, can anyone guess what the next element of our pattern is going to be? Now, I know that you probably have a ton of different ways that you might introduce patterns into your classrooms. This is one way. So we'll have, what do we think is the next element? What do we think is the next element? So we've got the square, the triangle, and square, triangle. And that's our code. And that was a quick and easy code. It uses sort of shapes. There's a lot of other ways that you can represent different codes as well. So here I've added a different pattern. We can ask the students, what do you think is going to be the next element? We can take guesses, have everyone can make a hypothesis or, that educated guess in their minds. And then we'll put up the next element. Okay, so a red C. Some people could have guessed a red C. Some students may guess that maybe the next letter is going to be an F. That is also would have been a good guess. Anything really at this point is a good guess. So let's see what the next element. Now, did anyone guess the red C? Now, this one was kind of a little bit tricky, and I chose it intentionally to be a little bit tricky. So we had the C, D, E at first that looked like it was the whole pattern. Now we added another C, and it still looked like it was going to continue with the same pattern, but then the next one was another red C, and that wasn't super obvious. So sometimes we need to be able to see the whole pattern more than once in order to be able to guess, a little bit further, so let me just elaborate on that idea a little bit more. So now, once I put the pattern up more than once we see that full pattern twice, it's a little bit more obvious that the pattern is C, D, E, C, or red, orange, yellow, red. And we can fill in the pattern again. We can guess what those final three will be. Perfect. Now, I picked this pattern also because it can be represented with sort of a different notation. So here, instead of C, D, E, C, I wrote it as the musical notes that those letters represent. So this is actually a song. It's a do, re, mi, do. So this is fun because it can show us that patterns really pop up in a lot of unexpected places. So this is another shape pattern. I like to think of it as small, small, big. And we can guess what will be the next element of the pattern. And again, we want to sort of ask ourselves, well, is this the whole pattern or is it not? Now, we don't really have any way of knowing. So we make our best guess with the information that we have. Small, small, big, small. Okay, so it's looking like we probably did have that full pattern at first. So small, small, big was the full pattern. So here I've got a big repeating number pattern. Can anyone tell me what this pattern would be? It's 4 digits. It's just repeating itself over and over and over and over again. And we can see that, well, it's a 1, 2, 1, 3. So we've done numbers, letters, shapes, music notes. Now this, again, can be a fun, like, this one can be a little more tricky. It isn't showing actually the full pattern, but you can use some of the information that's there to guess what will be the next element in that pattern. So the shapes again. So we had the 3 sides, the 4 sides, the 5, and then the 6. So that was a little bit trickier. So I want to shift a little bit to sort of illustrate a different kind of pattern. I'm going to show some images, and these 4 elements kind of make up a cycle and a repeating pattern that we see in our day-to-day lives. So I've got that first image up there. You can maybe start to guess what it's representing, the tree and the snow. Now I'm representing something else with a different image. It's the flower. And then we got the swimming pool. Some changing leaves, some autumn colors. So if you guessed that this cycle, this season, this pattern, this is the seasons, that this cycle is the seasons, then you guessed right. So we're starting off in the winter, then we move to spring, then we move to summer, then we move to the fall. So here's another way that we can sort of represent this. Now we've got, obviously, we have the sun and we have the earth, not to scale because the sun is way, way, way bigger than the earth in this. We here in Ontario, we are near the northern hemisphere. So we're in the northern hemisphere. We're near sort of the top part of the earth. And we can see as we go around, the tilt of the earth sort of moves, either we were over here, we were away, and then we move to over here, our northern hemisphere moves towards the sun. So the axis that the earth is turned at is actually what causes our seasonal variations. So we're going again, still around the sun. So here for us in the northern hemisphere, this represents winter for us because our little tip here, we're closer to the top, we're tilted away from the sun. Now, seasons in the southern hemisphere, so anywhere like, well, you see South America, South Africa, Australia, they have a different seasonal pattern than we do because of where they are located on the earth. So our winter is actually their summer. So here I've got this labeled for northern hemisphere seasons. Now, something else that's really interesting about the seasons, Well, not everywhere in the Earth feels that tilt the same way. So the people who are more near the equator don't have the same seasonal variations that we do in the Northern Hemisphere. So they have sometimes more like a wet season and a dry season rather than, the 4 spring, summer, winter, fall that we're used to. So here's our spring spot. Notice again, so the tilt isn't really towards or away from the sun. It's just sort of beside the sun. Here, now we're tilted summer, we're tilted towards. And then the fall, sort of neither. And that's that seasonal cycle. So anytime we can represent a cycle, a pattern, by a mathematical model, we can use it, for coding. So here's a different image that represents the seasonal cycle. It looks like, whoa, it's a little complicated for grade 1s at first, but let's kind of look at it. What are the first things that we notice about it? First thing that I see, I put in there on purpose, is the thermometer. This could be a good talking point if you are speaking to grade 2s. You might talk about, well, water freezes below 0 degrees, or you have liquid water if you're above 0 degrees. But here in this image, in this graph, I was using it to show the temperature. Now, another thing that we notice here at the top are the labels, J, F, M. So each of these represents something as well. Each of the bars here lines up with one of the letters. So these 2 bars line up with this letter, and like the numbers are low here. That means it's cold at this time. Then we move over here and it gets a little bit warmer, and sort of so on until we reach like the warmest time, the hottest time, and that's at this spot here that lines up with this J, and then so on and so forth. So hopefully the students will be able to notice that these letters are representing the months of the year. So we know that we have sort of the coldest months in the wintertime, right? Sort of December, January, February. You got March, April, May as springtime, June, July, August. So just another way to illustrate that seasonal pattern. So I'm just gonna put these, the images that we had before that illustrated that pattern back on top of this graph here, to the corresponding months, right? So we got December, January, February, March, April, May, so on and so forth. So here is our seasonal cycle again. So when I mentioned earlier, when we looked at the shapes and some of those different patterns, it's hard to tell that something, if you're not seeing the whole pattern all at once, what you're really looking at. So what I did here is I put both, or I put 2 years worth of those average seasonal temperatures. I think I forgot to mention, those are average seasonal temperatures for Sudbury, Ontario. Depending on where you are at, that your seasonal temperatures may be warmer or colder. So we've got 2 years here. Now I put 3 years, sort of back to back. And this helps us to see, once we see the pattern repeated over and over again, it helps to really see that it is a cycle, it is a repeating pattern. So and this is why we can use the seasons as a mathematical model. So all of that to sort of bring us to the first activity. So the first activity that we're proposing is sort of a Simon Says, where once you've presented all of these, the seasonalities and the patterns, you want to associate maybe different activities with a different season. So one of the ways that you could sort of go about this is have students sort of make a list of things that happen in a different season, and you sort of call out Simon Says, Simon says it's snowing, and the students will have picked an action. Now, something I think is an interesting idea that you may want to do in your classroom, you can present to them and show them the four different signs for the seasons in American Sign Language. So rather than having sort of students pick like a random action to represent the seasons for the Simon Says game. They can learn the sign language or the signs for each of the seasons. So for example, the season for winter is like, I'm just trying to get in my frame here. So winter's like, it's like cold, right? It's, and this might actually be a natural, sign that you might choose, but this is the sign for winter. So if I say Simon Says it's snowing, the students say, oh, it's winter. If I say Simon Says we're going swimming, then it's summertime. Simon Says it's Canada Day. Oh, it's still summertime. You can start off by going through the seasons or actions associated with them sort of randomly, and then you may want to fall into that pattern, into that cycle. And then the students should be able to predict which thing comes next. So you can, generate the list of sort of Simon Says yourself or work with the students. They can generate some ideas, maybe different holidays that might be, culturally relevant to your group. So if it's the first day of school, then that means it's the fall, right? So something that Brendan's reminding me, I forgot a little bit, so thank you, Brendan. I want to relate this to conditional statements. So patterns are part of code, also conditional statements. So when we're giving those set of instructions to the computer, the set of code of how to go through, from point A to point B, we use something called a conditional statement. So the conditional statement gives the computer sort of a decision tree, a decision sort of making process. So if it is this thing, then also it means this. Now I did a poor job of explaining that right here, right now, but I'm going to elaborate a little bit more on the conditional statements in my next couple of slides here. So we want to relate our patterns to patterns that are in nature, because the two concepts that, again, we want to illustrate are loops and conditional statements. So we obviously saw with the seasons that the seasons loop, they cycle, that's a loop. So here I've got another little pattern here. I realized when I did this practice presentation, someone told me the bunnies didn't necessarily show up in the right color for everyone. So I should have like white, gray, brown, gray. So because all of the living things within the earth need to follow and adapt to those different patterns, we can apply, oh, this is the same slide again. Those seasonal changes and that mathematical modeling to things that different living things might do in those seasonal changes. So this is a nice sort of illustration. Trees go through that excuse me, seasonal cycle. And all the animals also follow those seasonal cycles. So different creatures are going to have to adapt differently depending on that season. So these are fun. I think they cue a season for a lot of different people. You know that the fall is coming once the geese are starting to migrate. This is a really interesting bird. It's called the Arctic tern, and it performs one of the longest migrations of any creature. So they actually migrate pole to pole. So they spend the whole year in their respective summers. So if it's summer at the North Pole, they're at the North Pole. They don't want to spend winter at the North Pole, so they go to the South Pole for their summer. So this is another interesting creature. It's a monarch butterfly. It's an insect that migrates. So most insects, I wouldn't say migrate, so that's why that one's kind of special. This is an Arctic fox. Their coat changes, not unlike that bunny that I was trying to illustrate. You had him changed from the white coat to the gray coat and then the brown coat because they'll camouflage differently in those different seasons. Now we have a caribou. They will shed their antlers seasonally, so that's an interesting adaptation. And we have these cool bats that hibernate. So I'm missing some things. Sorry, I'll just go back a little. Previous. So we want to take all of those things that we looked at and build them into the coding activity. So the coding activity here, we're looking at, again, loops. So how might we introduce those, how might we look at the seasons and put them into a loop? Now, a really good example, I had a code a little bit earlier. I had a pattern. I had a 1, 2, 1, 3, and we saw that one way that you can put into a longer code is to repeat that same code over and over again. Now, if we were to build a loop with that 1, 2, 1, 3, you only have to write it out once. And then you can repeat that loop. So we can see that sort of illustrated here. If we were to illustrate a seasonal loop with our code blocks, this green block sort of always represents, this is the starting point. We've got the spring, the summer, the fall, and the winter. Now this code here would loop this season 10 times. So we would have a 10-year sort of seasonal cycle. Here, we can use this symbol here to have that repeat indefinitely. So another important part of this activity, and here's where I'll try to explain conditional statements a little bit better. So the conditional statements are a really crucial part of coding because, again, it's going to give the computer a sort of decision-making process. So if a certain thing, then a certain thing. So here I've put out some examples that you might want to use with your students. So before sort of relating to code in any of our coding platforms, we want to look at them, how they might go, how we might build an if-then statement in our sort of day-to-day life. Now I've put some examples here. If anyone has some better examples, I'm not like really in with like grade 1 and grade 2 kids. Like my kids are a little bit older now, so I'm not sure like what really resonates with that sort of age group. So if anyone has some different ideas, like certainly call them out. So at school, if the fire alarm goes off, then we need to line up, or whatever is going to be like your sort of classroom procedure. If I arrive to school late, then what is the consequence that happens there? So students can either come up with their own if-then statements or sort of fill these in. Now, when you look at some of these examples, in sports games, if I play an 8, then, well, some of them we might need a bit more information, and that's kind of like when you're looking at that at the bit of the pattern. If you don't have the full information of the pattern, then sometimes there may be more than one option, right? So I've got if the bell rings, then, well, is it the beginning of the day? Is it the end of the day? Is it near lunchtime? Is it near recess? So the bell could mean different things at different times. So if you've got gadgets or weather, if it's raining, you might have a lot of different sort of consequences then. If it's raining, then I wear my rain boots. If it's raining, then we have recess inside, or other things that might happen. So here, I hope I did a little bit of a better job explaining the conditional statements. Now, where I was trying to get to with that Simon Says, if it's snowing, then it's wintertime. Okay? And not 100% necessarily, but if it's Thanksgiving, then it's the fall. So that's a good way to relate those conditional statements into that Simon Says game. So where we've got the loops and the conditional statements. So the last part of this sort of set of activities will be a coding activity and drawing conditional statements. So in one of the handouts that we've got for your lesson for today, we've got a copy of this sort of blank template where the students will be encouraged to come up with their own conditional statement relating to some of the animals, some of the seasonal creatures. It could be something related to themselves as well. So let's see, so here I've got an example where we sort of follow a bear through the seasonal cycles. So this is fun. You might want to assign an animal and a season to a student and assign sort of each of the seasons to different students. Afterwards, they can put their conditional statements together to create a loop for the whole year. So either students can build sort of an if-then statement for one season or do an if-then statement for their animal for each of the seasons. So if it's winter, then this bear is hibernating. If it's springtime, he's waking up. If it's summertime, then he's eating. And I think in the fall, well, he's getting ready to hibernate. So we have each of those seasonal if winter, then, condition. And this is what it would look like once we put them all together into a loop. So we start off, we've got the spring until the summer and the fall. Now we can see here, so when, this is just our starting block. This is always our starting block. We can see down here, that symbol says to loop back, right? So it's step 1, step 2, 3, 4, and then loop back. And we can see here where it says forever, that is going to be a forever loop. So now when I would like to do my very best to answer any questions that anyone might have related to any of the material that we have covered so far. Now for our next session together, I'm going to be using a program called Scratch Junior. So if you want to follow along, I would recommend that you download the app either on a tablet. So if you're doing it on a tablet, you can download the app to a tablet, and it's touch base. There's no text, so this is a program that's meant for sort of the youngest readers. So you'll want to get that program ahead of time. If you don't have it on a tablet, you can download it to a laptop or also to your desktop. So this is neat because if it's attached there, then you can use it on your smartboard with your classroom. So that is, you would download that desktop version. Now, if you try from a desktop to download the app that is for tablets, you won't be able to. So there's a little bit of tricky business there. But if you wanted to download that ahead of time, that would be great. If you have any issues, you can get in touch with us, and we can hopefully get you going before tomorrow's session. So let me just check here. So here I've got a thank you for joining us. There's a QR code here for a survey. Now, another thing that I'd like to sort of highlight is this educators@sciencenorth.ca email address, sorry. So this educator's email address is dedicated to this specific project. So if you have any questions about any of the resources, about how to download, any of the programs, we will obviously do our very best to get back to you as soon as possible, within the day, and we can either set up a call, hopefully to help you iron out any issues that you might be having. If you need any other ideas or anything, we are there to help. So we've got that educator's email address set up there. So for next time, if you want to download that Scratch Junior, that's where we're going to start our next session. And otherwise, I want to thank everyone for joining. It feels nice. I didn't really get to see too many people, but I did see there were people in the stream, so that kind of feels nice to connect with folks. So thanks again, and take care. If you have any questions, please shoot them our way to that educators@sciencenorth.ca website. So thanks again. Take care.